Hello kids, welcome to my channel CBSE Math Gyan. So the chapter which we are going to do today is triangles. Triangles we have been doing from 7th grade, 8th grade. We have seen what triangles, different types of triangles are, what is scalene, equilateral, isosceles. We have also seen the congruencies also. So in 9th grade, what is it? It is just the applications of whatever you have learned, application based questions in 9th grade. Mostly it is of congruencies and inequalities. Now before we start with the triangles, I thought that you should be knowing certain terms which often or frequently come in the questions. You should be familiar with these terms before you start solving the problems on triangles. So what are these terms? I made a list of the terms. Let us just have a quick review of what all these things are. Then we can go for the congruency test. So very first term which I have written is intersect. So usually the kids get very confused when the word intersect, bisect comes. So it is very easy to understand. Intersect means whenever one line is cutting another line. It can be a line or a line segment. When it is just cutting, passing through a single point or cutting another line, we say it intersects. We can say a line AB intersects PQ at O. So intersect is just cutting. Now what does bisect mean? Now bisect has a particular meaning. When we say bisect, it means it is cutting a particular thing but in two equal parts. Bi means two. So two and that two equal parts. So it is called as a bisect. So the same thing if I say a line AB bisects line PQ. This is my line PQ. A line can never be bisected, so it has to be a segment. That only will be having equal parts. A line is actually continuing. A line segment has specific length. So I will say a line AB, this is a line AB, is bisecting line segment PQ. Bisecting, the word bisect means it is cutting this PQ into two equal halves. The moment bisect word comes in the question, you should be knowing that the first thing what you are going to do is you are going to make this mark showing that these two particular parts PO and OQ are equal. So the term bisect means it is cutting it into two equal parts. Now this is called as a bisector. AB is said to be a bisector of PQ. There is a line bisector also. There is an angular bisector also. We will see that thing later. Bisect means cutting it into two equal parts. What does trisect mean then? Cutting it into three equal parts. So the word trisect means the moment trisect word comes in the question, you should be knowing that the line has been divided into, the line segment has been divided into three equal parts. So I will say my this part is equal to this is equal to this. My AB is equal to BC is equal to CD. So the AD line has been trisected at points B and C. Clear? So intersect is just cutting, bisect equal parts in two equal parts and trisect in three equal parts. Now next comes the perpendicular bisector. Now the moment perpendicular bisector, we know what is a perpendicular, a very common term used in geometry. This is going to be a perpendicular. When I say AB and PQ, I can say PQ is perpendicular to AB or AB is also perpendicular to PQ, correct? Now what is a perpendicular bisector? It is perpendicular as well it is bisecting. So when I am saying PQ is a perpendicular bisector of AB, it means it is perpendicular to AB and it is cutting AB into two equal parts. So it becomes a perpendicular bisector. Now I have mentioned the word over here. PQ is perpendicular bisector of AB. The PQ is perpendicular bisector of AB. Is AB a perpendicular bisector of PQ? We do not know. AB can cut this PQ. Maybe this might be 5 cm, this may be 3 cm. It may not be equal. But PQ is cutting AB into two equal parts and it is perpendicular also. So PQ is a perpendicular bisector of AB. You should know this thing properly. I am saying PQ is a perpendicular bisector of AB. AB not the perpendicular bisector of AB. So you should know the difference. PQ is PQ is cutting AB and PQ is also perpendicular to AB. So that is a perpendicular bisector. Next is a angular bisector. Again, as the name suggests, I have written over here angle, it is actually angular bisector. What does it mean? It divides the angle into two equal parts. So if in a triangle, suppose say x, y, z, and it is said that YO is the angular bisector. When the word angular bisector comes, it means that YO is dividing this particular angle at the vertex Y into two equal parts. So this angle is going to be equal to this angle. So XYO is going to be equal to OYZ. So the meaning of angular bisector is the bisector or the line which is going to cut the angle into two equal angles is a angular bisector. So these are the different terms which will be used for your problems. The moment you know the terms, you should be able to mark those terms accordingly in your figure. You should make your figure more descriptive. The moment you see the figure, you should know all the information what is there in your question. That's why I am saying this. Angular bisector, the moment angular bisector is coming, you are going to mark these two angles equal with the same sign. Clear? Next comes the median. Now what is a median? We know what is a midpoint. Now median and altitude are the term usually used for triangles. So now in a triangle, suppose my triangle is ABC. My triangle is ABC and I am saying AD is the median. AD is the median. What does it mean? Median means it is a line segment which is joining the vertex of one angle with the midpoint of the side opposite to it. Midpoint of DC is D. The moment I am saying midpoint of BC is D and I am joining AD to it, A to D, AD is going to be my median of the triangle. So when I am saying AD is the median of the triangle, the moment you are reading such a thing in your problem, AD is the median of the triangle, what you are going to do is, you are going to mark these two equal. Why? Because median is the one which joins vertex with the midpoint of the side opposite to it. So in a triangle there will be three medians. One is this way, I can draw one this way, I can draw one this way. So these two will be equal and I can say these two are also equal. Correct? So I can say E and F. So my BE and CF are also the medians. So the word median means joining the midpoint of the side and the vertex of the opposite angle. That particular line segment is called as the median. So over here AD is the median, BE and CF. The moment median word comes on the problem, you have to accordingly mark the figure. Next is altitude. As we know altitude, we also say it as height, but usually in geometry we say the word altitude. Now, what is altitude? It's the height or the perpendicular. So when I am saying ABC and I am drawing this thing, suppose this is AD, my AD is the altitude of triangle ABC. AD is the altitude, A is perpendicular. I am drawing from this vertex to the opposite side a perpendicular, that AD is going to be my altitude. So again altitude also I can have three altitudes. I can have three altitudes for a triangle. Now altitudes are the perpendiculars and medians are the ones which I am going to PQR. So suppose this is the median, PM is the median, means it is dividing this thing QR into two equal halves. Can a median and a perpendicular be the same? They are not the same, they are different, but for a particular triangle they will be same. We will see that thing for the equilateral triangle and for the isosceles triangle. Got till now? What is intersect, bisect? Intersect means just cutting the two lines, bisect means cutting it into two equal parts. Trisect means cutting it into three equal parts. Perpendicular bisector means it is perpendicular as well as it is bisecting. Angular bisector means the line which is dividing the angle into two equal parts. Then median is from the vertex to the midpoint is the median, and altitude is from the vertex perpendicular distance. Now over here median is always, this PM will always be in the interior of the triangle. Interior of the triangle. Medians are always in the interior, inside the triangle, because we are trying to finding out the midpoint of this point, and then we are drawing it. Altitude can be in the interior, it can be in the exterior also. Over here it is in the interior. I can show you a triangle in which it is in the exterior also. In an obtuse angle triangle, suppose say x, y, z. If I want to draw a perpendicular, if I want to draw a median, what I will do is, from here I am going to take a midpoint over here. Xm is going to be my median, correct? And what about the altitude? I am going to extend it over here, and I am going to draw a line which is going to be my, suppose this is P. So XP is going to be my altitude, which is outside or exterior. So it can be interior also, it can be exterior also, the altitudes. But medians are always in the interior. Now we will see about the equilateral and the isosceles triangles. Now we will see about the equilateral triangle. There are some facts about equilateral triangle which if you know, it becomes easier for you to solve the problems. Now we know equilateral triangle, all the sides are equal as well, all the angles are also equal, all the angles are 60 degree. Apart from this, there is one more fact about equilateral triangle is, if you are drawing an altitude of an equilateral triangle, or if I say I am drawing a perpendicular from A to D, it is a perpendicular. This perpendicular is also going to be a perpendicular bisector. It is going to be a median also. So for an equilateral triangle, my AD is going to be a perpendicular bisector also. It's a perpendicular means AD is my altitude. AD is also my median. Why it's a median? Because it's a perpendicular bisector, it bisects this thing equally. So it's a median also, and it is also angular bisector. It's also the angular bisector of angle A. So my AD, it is the same. The median, altitude and angular bisector are all the same for an equilateral triangle. It is not true for any other triangles that medians, altitudes are all different. But for an equilateral triangle, the AD is going to be a perpendicular bisector also, it's going to be a median also, it's going to be an angular bisector also. Clear? Now, we also know that the sides of an equilateral triangle are equal. Suppose the sides are AAA. So what is the height of an equilateral triangle? How will you find out the height of the equilateral triangle? Suppose say AAA are the sides of the equilateral triangle. So what will be my side BD? BD is going to be A by 2. Correct? Since AD is my median also, it is going to be A by 2. So by Pythagoras theorem, can I find out the height of AD? I can find out AD as root of A square minus A square by, I can write AD square is equal to A square minus A square upon 4, which is equal to 3A square upon 4. Therefore AD is equal to root 3A upon 2. I used the Pythagoras theorem for the triangle ABD and found out the height. So it shows that if an equilateral triangle has a side A, then its height is root 3A by 2. So these all things should be very much thorough for you. For an equilateral triangle, altitude, median, angular bisector are all the same. As well, when its side is A, the height is root 3A by 2. Now, whether this same thing follows for an isosceles triangle, let us see. Now, for an isosceles triangle, you all know that for an isosceles triangle, two sides are equal, two angles are equal. Those are called as base angles. So, if I am drawing an equilateral isosceles triangle, suppose this is an isosceles triangle PQR, where my PQ is equal to PR. So, this is an isosceles triangle. These are my base angles. These are called as base angles, angle Q and angle R. The angles which are opposite to the equal sides are the base angle. This is called as a vertical angle. This is called as a vertical angle. We know all these things about isosceles triangle. Now, one fact about isosceles triangle is that when an isosceles triangle is placed in this way, such as the base angles are down, and I am drawing a perpendicular from my vertical angle onto the base, suppose say PM, This PM is again going to be a perpendicular bisector also. So it is going to bisect also. It is going to be perpendicular as well as it is going to bisect also. So my PM is going to be my median also, and it is going to be my altitude also. For an isosceles triangle, only when I am drawing it from my vertical angle to the side opposite to it. That particular median is going to be the same as the altitude also. So it is perpendicular also and perpendicular bisector also, median also. So the moment isosceles triangle is given in the question, first thing you want to mark the equal sides, equal angles, and if from the vertical angle they have drawn either a median, then you should know that it is not only a median, it is also a perpendicular. Or if they are asking for a perpendicular, then it is not only a perpendicular, it is also a median. So accordingly you should be able to mark the things. Clear? So this is about the isosceles triangle. So these are certain facts which you should be knowing. So when you start solving the problems, you should be able to mark these things in your figure so that it becomes easier to solve and implement it. Now the angle sum property and the exterior angle property, we have done it in the lines and angles chapter. So what is the angle sum property? The easiest one of all. If an triangle ABC is there, we all know angle A plus angle B plus angle C is 180. This is the angle sum property. Angle sum property. What is the exterior angle property? If I am drawing an exterior angle, what do I mean by an exterior angle? I am stretching out or extending one of the sides of my triangle out, and that particular side and the other side of a triangle should make an angle. That angle will be my exterior angle. I cannot say this as an exterior angle. This angle is not going to be my exterior angle. Though this is the extended side, this is also the extended side, but the angle formed should have one extended side and one side of the triangle. Only then we will say that it is the exterior angle of the triangle. So over here if you see, if I write this as D, my CD is extended part of BC. BC I am extending so that this BD is the whole extended line. So my angle formed is having one of the extended side and one side of the triangle. Only then the angle formed is the exterior angle of the triangle. So what is the exterior angle property? Exterior angle property is the exterior angle is equal to the sum of the two opposite interior angles. Now what are the opposite interior angles? Interior angle of this is this, and opposite of these two are these two angles. So what is the opposite of the two opposite interior angles of this exterior angle? It is going to be A and B. So what is my exterior angle property? Angle ACD is equal to angle A plus angle B. Angle ACD, I cannot write it as only C because C at this point has two angles, ACB and ACD. So I have to specifically write the whole thing, angle ACD. This is my exterior angle which is equal to angle A plus angle B. So this is my angle sum property and this is the exterior angle property. Clear? Exterior angle property. One more we can do. Can I extend this thing over here? Yes, I can extend this thing over here. Then which will be the angle formed? This is the angle formed. So suppose this is F. So what will it be? ABF. ABF will be equal to A plus C. Angle A plus angle C. So these are the exterior angle property. Clear? So this is all you have to know for the triangle chapter. And now we'll start with the congruencies. The different types of congruencies are SAS, ASA, AAS, SSS and RHS. Now what does congruency mean? When I am saying one thing is congruent to other, when I am saying the two squares are congruent to one another, what does it mean actually? It means when I say PQ ABCD is congruent to PQRS, it means when I am placing this PQRS on ABC, it should exactly match. Means my P should exactly match with my A, Q on B, R on C and S on D. Then I will say that ABCD is congruent to PQRS. It should be an exact match when I keep it one shape on the other. The same thing is true for triangles also. when a triangle is kept exactly on the other triangle and it matches with the vertices and the sides, I will say they are congruent. So, if these are the two triangles I am having, ABC and PQR, if I am placing this PQR on ABC and exactly the vertices match and the sides also match, everything matches one exactly, it can be kept on one another, then I will say that ABC is congruent to PQR. The word used is congruent. We do not say equal, we use the word congruent when it exactly matches. And symbol used is an equal to sign with this thing. So this is a sign for congruency. The word used is congruent. Now, when we say it's congruent, when it exactly matches, means my angle A has to be equal to angle P, angle B has to be equal to angle Q, angle C has to be equal to angle R. All the three angles have to be equal. Other than that, even my sides also have to be equal. My AB has to be equal to PQ, my BC has to be equal to QR, and my AC has to be equal to PR. When all these conditions are satisfied, I will say that ABC is congruent to PQR. When all conditions means when all the angles are equal and all the sides are equal, then I say ABC is congruent to PQR. Now every time it is not possible to check each and every angle and each and every side. That is why we have this congruency rules. Only if three conditions among these six are satisfied, we will say that the two triangles are congruent. We have seen this in 7th and 8th grade. So only three conditions are necessary to prove that the two triangles are congruent. We do not have to sit and prove all the six of them. So these three conditions are given in certain rules. The very first rule being SAS. Now what does this mean? SAS. Now I will change these names. So every time we are taking ABC, it becomes very easy. What we will do is, we will give a name A, X, P, R, T, W. Okay, let us make it little bit confusing so that let us see the concept of SAS and then we can see how it is followed. Now what does it mean? SAS means I am saying that only three conditions are needed to prove that these two triangles are congruent. What are the three conditions? SAS, side, angle, side, means two sides and one angle. But they have to be in this particular order only. They have to be in this order. What is this order? The angle is between the two sides, or we say the two sides are making the angle. When the two sides are making the angle, this angle is called as the included angle. The word used is included. So if two sides and the included angle of one triangle is equal to two sides and the included angle of the other, then we say that the two triangles are congruent. We did not prove all the six conditions, all the three angles and all the three sides. Only these two sides and the angle between it. What does it mean? Suppose AX is equal to RT. See the marking I am giving the same markings on the two triangles. Whatever mark I have given here, over here the same mark indicates that this side is equal to this side. So AX is equal to RT, and I will say, suppose say my XP is equal to TW. Now over here I have given a different sign. If I would have given the same sign, it would be that this is also equal to this. I have given a different sign signifying that my XP is equal to TW. I could have taken AP is equal to RW also, any two sides. Now the angle which has to be included is an included angle, means it's the angle formed by these two particular sides only. The sides which are congruent are forming the angle. So this particular angle is called as an included angle. These sides which are congruent are forming my angle. So the moment they are forming my angle, this is called as an included angle. So now what is the thing? It is SAS. So only these three conditions are enough to prove that these two triangles are congruent. So what is congruency rule over here? It is SAS. My S over here was, what was it? It was AX is given equal to RT. AX is given equal to RT. My XP is given equal to TW. Correct? and the angle included. Any other angle if it is there, it is not going to show me congruency. The angle has to be in between the two sides. The angle in between these two sides is angle AXP is equal to angle RTW. When these three are given, I can say it is an SAS congruency, or by SAS congruency, I will say by SAS congruency, the two triangles congruency rule, my triangle AXP is congruent to triangle RTW. So two sides and the angle should be included in it. Then I will say that they two are congruent. Now when I am saying congruent, there is a particular way in which we are going to write the congruency. You should be very particular in how you are going to write the congruency terms. The thing how you are going to write is going to explain the whole concept. Now over here, when I am saying the two triangles are congruent, I could have written any way. It was AXP, I could have written congruent to RWT. Anyway, I can name the triangle. I can name it AXP, PXA, RTW, TWR, anyway. But when I am writing a congruency, I should be very particular on what I am writing over here. The congruency should exactly match. As I said, when we say congruent triangles, one has to be kept on the other, it should exactly match. And that is the way in which you are going to write it also. So over here, how you are going to write it? The first triangle you can give any name, but accordingly you are going to match and write the second name. A has to match with what? Now A, if you see, has to match with what? R. How you are going to know over here? First thing what was given was your X is matching with T. AXP means the angle is at X. The center one is telling me where the angle is. Correct? So AXP means my angle is at X and RTW means my angle is at T. So my X and my T are matching. My X and my T. So the center one has to come as T. Correct? X and my T are matching. Now next one is my A. My A is to be X and T are matching. If you see one of the things, X and T are matching, then what else is matching? My A and R are matching. If my X and T were matching, A and R are the remaining ones which are matching. So when I am writing over here A, the second one over here has to be R. So A was the first term over here. So R has to be the first term over here. Now next one is P. Now if you see X and T are matching, X and T we got it from the triangle angles directly. Now for the next one, X and T are matching. What are the remaining one? P and W. Where is P? P is the third one which we have written. So we are going to write W as the third one. So what did we wrote? Right? We wrote AXP is congruent to RTW. Means A angle is congruent, exactly equal to R. My A is exactly equal to R. My X is exactly equal to T. X is equal to T. P is equal to W. This we found out only by giving three conditions over here. SAS, two sides, included angle if they are equal. My two triangles are congruent. How am I going to write the two triangles? I am going to write first the name of the first triangle and then I am going to search the hints from here and write the name of the next triangle. Clear? So this is very important how you are going to write the congruency later on. Once this has been proved, what are the remaining three conditions? Three angles should be equal and three sides should be equal. Now over here one angle is given. Which two angles are remaining? Angle A is equal to angle R. Then angle P is equal to angle W. Then two sides are given. So third side is remaining. Which side is remaining? XP is given. Okay. AP is equal to RW. Correct? So these were the remaining things. Once these are congruent, these things follows. Or what we say is, we say this thing as CPCT. What does this CPCT stand for? Corresponding parts of congruent triangles. Congruent triangles should have totally six things equal, three angles and three sides. Two sides and one angle was given. So remaining two angles and one side is remaining. This could be proved only when the triangles are congruent. This was enough to prove me the triangles are congruent. SAS congruency, the triangles are congruent. Therefore, I have very carefully written the congruency, and from this I got this remaining parts. Now even without seeing the diagram also, I can just by seeing this particular thing, I can write this. See, if angle A has to be equal to angle R, just see the corresponding. A is equal to R, correct? X is equal to T and P is equal to W. So X is equal to T is already given, P is equal to W we wrote, then AP, first and the last one, is equal to first and the last one, R, W. Clear? So this is how we are going to do the congruency. So I am elaborating the first part, the rest part we will just do it in a short way. So what we did is, two sides and the included angle, when they are congruent, we say that the two triangles are congruent. So the remaining three parts we will write as CPCT, corresponding parts of congruent triangles. Now what is the second rule? Second rule is ASA. Suppose there are two triangles. Now I am going to directly write this as, suppose say XYZ and AMQ. We will give some different names so that we will be thorough with what we are doing. Okay. These two triangles by ASA, as the name suggests, two angles and a side, again two angles and the side in between them. Two angles and the side in between them. If they are equal, then the two triangles are congruent. So if I am saying this is one angle equal to the other angle given, suppose that this angle is given equal to this angle, you should notice the signs which I am using. Same sign I am using for equal angles, same sign I am using for equal angles, but these two signs are different. Okay, so my X is equal to M, P is equal to Q, and my third side has to be the one in between these two angles. Then only it is going to be an ASA test. So third side has to be this one. If my side was YP, it will not work. It has to be a side in between these two angles. Then I will say that these two triangles are congruent by ASA test. So how am I going to write the congruency over here? Now I am going to directly write the congruency. Let us see, we will write the congruency as XPY. We will write it in different order and see. XPY. Now how am I going to write the congruency over here? These two are congruent by ASA test. I am not writing the details of it. We can write it. What is given? Angle X is equal to angle M, angle P is equal to angle Q, XP is equal to MQ. Therefore, by ASA test, the two triangles are congruent. After that, what you are going to write is the congruency. Triangle XPY has to be congruent to what? Now we know that X is congruent to M. So first thing, X, instead of here, it is going to come as M. The second thing was given as P was congruent to Q. Where is my P? The second one. So here it is going to be Q. And what is the third one remaining? Y. Over here third one remaining is A. So I can say my XPY is congruent to MQA. This is by ASA test. ASA congruency. Before that you have to write which all sides are congruent to what and accordingly. For ASA, two side angles and the side in between the two angles. Then only it is going to have an ASA test congruency. Congruency is true. From this congruency, the moment this is given, you should be able to write all the 6 of them. 3 of them were already given. What remaining 3 we will write? What are the remaining 3? Now angle Y was not given. Angle Y should be equal to, this is the last one over here, this is the last one over here, angle Y should be equal to angle A. Is angle Y equal to angle A? Yes. Then what else is remaining? Now side PY. PY should be equal to QA. Second and third. It should be equal to QA. PY should be equal to QA. And next one is XY. X and Y. X and Y, first and the third should be equal to MA. XY should be equal to MA. This is the way in which you are going to write the remaining parts, and how it is, you are getting the remaining parts by CPCT, that is corresponding parts of congruent triangles. Clear? So first one was SAS, 2 sides included angle, second one was ASA, 2 angles included side. Then it is going to be congruent. Now the third one is AAS. Now AAS actually is not a congruency rule, but from AAS we can write it as ASA. We will see this. Third one is AAS. Now suppose the two triangles given are PQM, EAX. Okay, the two triangles are given are this. Now if two angles are equal, suppose this angle is equal to this, suppose this angle we will write it is equal to this. Okay, two angles are equal, any two angles are equal and the side is equal, any side is equal. They are saying two angles and the side is equal. Suppose say this side is there, this side is equal to this, means PM is equal to EX. They are saying that even when any two angles and a side is equal, the two triangles are going to be congruent. Now how it is going to be congruent? If you see, we know by angle sum property. What is my angle sum property? This plus this is going to give me 180, correct? This is my angle sum property. Suppose say this was 30 and this was 70. Suppose say this was 30 and this was 70. What will this angle be? This is going to be 100. So angle M is going to be equal to 180 minus 70 plus 30, which is 180 minus 100, which is going to give me 80. So this angle is going to be 80, correct? If this was 30 and 70, this angle is going to be 80 by angle sum property. Same, I am saying that this angle is equal to this. So this is also 30. This is equal to this. This is also 70. So this is going to be 80. So if you see, if any two angles are equal, if any two angles are given equal, automatically third angle also has to be equal, correct? So my third angle is equal. Now I can say that it is an ASA test. ASA. ASA. Correct? 80, 80, 30, 30 and the side included in it. Correct? So it is following my ASA test. So AAS is just an extension. We can prove it according to an ASA test. So what it is saying is, if any two angles and the side is equal, we can say that the two triangles are congruent. If any two angles are equal and the side is equal, the two triangles are congruent. Clear? So over here what I said is, any two angles I have taken and any two angles are equal and one side, any side. Suppose if this side was not there, we will take another side. Any side you take, two angles and a side. Suppose this side. This side is equal to, it has to be equal to this side. Okay. Any two angles and a side is equal, then it has to have a AAS test. Let us see. It is going to be angle, this is equal to, angle P will be equal to angle X, angle. So by AAS congruency rule, I can say that triangle PQM is congruent to triangle. Now how I am going to write? PQM is congruent to which triangle? P is equal to angle X. So my P is equal to angle X. So first P, so first X will come. Second is Q. So second will come as A over here. Second was Q. I am going to write an A over here. And third is whatever is remaining, M. And over here what is remaining is E. So how did I write my congruency? PQM is congruent to XAE. This is my congruency. So if I keep my triangle in such a way that X has to match with my P, Q has to match with my A and E has to match with my M, the two triangles are going to be congruent. These are congruent by AAS congruency. What is AAS congruency? Any two angles and one side. Any side. Any two angles and a side, the third, this is going to follow the congruency rule. AAS congruence, we have written the congruency and then we will write the CPCT. What is remaining? Two angles were given. Third angle is angle M. Angle M will be equal to, this is the third one, is equal to the third one, angle E. If you see angle M is equal to angle E. We got it as 80-80. Angle M is equal to angle E. What are the remaining sides? QM was given, PM is remaining. So PM first and last is equal to XE. So my PM is equal to XE. Same way my, what else is remaining? PQ is equal to XA. PQ is equal to XA. And how this has come? By CPC. So the third rule was AAS, any two angles and a side, it means that it is going to follow as ASA only. So three congruency rules are SAS, ASA, AAS. Similarly, another rule is that SSSS, all the three sides are equal. Again, the two triangles are going to be congruent, and we can write the congruency along with the CPCT, all the other parts also. So the third rule will be, what we will do is, we will quickly write the third one also. You should be able to know how to write the congruencies. Then there is no need of the diagram also. Just by seeing the congruency also you can write it. Suppose it is X, P, M, A, W, R. Three sides are equal. This side is equal to this. This is equal to this. This is equal to this. These are all given. If the three sides of the triangle are equal, then the two triangles are congruent. Three sides are given equal. The two triangles have to be congruent. Whatever is given, we can write as PM is equal to AR, PM is equal to AR, then XM is equal to AW, and XP is equal to WR. This was given. All the three sides are equal. Therefore, by SSS congruency rule, the two triangles are going to be congruent. Which two triangles are going to be congruent? Now we will write the triangles. Triangle, suppose say XPM, I am writing triangle XPM is congruent to which triangle? Now X is over here. Is there any hint over here? No. So what we are going to do? We are going to say XP is equal to WR. It can be WR or it can be RW. We will see it. First we write it as WR. XP is equal to WR. Second is XM. XM is equal to AW. XM is equal to AW. So if I write it as A, XM has to be equal to AW. So it has to be WA. Correct? If you see, my X over here is common. In these two terms, XS is common. Over here what is common? W is common. So my X is equal to my W. So X has to be equal to my W. In this particular thing, MM is common. Over here, AA is common. So M has to be equal to A. So my M is equal to A. If this two, if you see, PP is common over here. And in this two, RR is common. So my P has to be equal to R. This is the way in which I wrote the congruency for my SSS test. Once the congruency has been written, then I can directly write the angles. Angle X is equal to angle W. Angle P is equal to angle R. And angle M is equal to angle A, all by CPCT. Angle X is equal to angle W. So if you see, the X is having two sides. One side is of this side and the other side is of this side. Same way W also. One is having this side and one is having this side. So it is exactly matching. Same way P, if you see, angle P is one side is one single mark, second side is two marks. Same way over here, P is equal to R. R is having 2 marks and 1 mark. This way also you can match and see. This thing has to be accurate. When you write this thing, you can write the remaining part and write CPCT. Clear? This is about SSS test. Now the last one is RHS. Now RHS, as the name states, RHS means right angle, hypotenuse and side. It is a right angle. So both the triangles have to be right angle triangles. Then the hypotenuse has to be equal. Hypotenuse has to be equal. And one of the side has to be equal. So it is right angle, hypotenuse, side. If the two triangles are right angle triangle, their hypotenuse are equal and one of the sides is equal, then the two triangles are congruent by RHS congruency rule. Now let us see how it is. The moment a right angle comes in the question, you search for another right angle triangle. If they are congruent by RHS, the two triangles are congruent. Now suppose if these are the two triangles, they have to be a right angle triangles. Suppose this is PQR and this is WMX, and it is given, since two right angle triangles means two angles are 90 degrees, the hypotenuse is the side opposite to the right angle. It has to be equal, and any of the side is equal. Any of the side is equal, hypotenuse equal, and it's a right angle triangle. By RHS congruency, these two triangles are going to be congruent. Let us see what is given. It's given as angle Q is equal to angle M, which is 90. Both are right angle triangles. PR is equal to WX. Hypotenuse is given equal. Now what is given? QR is given equal to WM, and one side is given equal. When this is given, then by RHS congruency rule, the two triangles are congruent. Now which two triangles are congruent? These two triangles are congruent. How are we going to write the congruency? First we write the name of the first triangle, PQR, and while writing the name for the second one, we have to be very careful. What is the trick over here? First search for the right angle. Which is the right angle over here? Q. So where is Q over here? It's in the center. So which is the right angle over here? M. So M also has to be in the middle. Okay. Wherever there was a Q, it's a right angle, there M also follows. Now for the other two sides, if you see over here, in these two same things, R is common, over here W is common. Over here R is common, here W is common. So wherever there was an R, there will be a W in the other one. So R is on the third place, so there is going to be a W on the, and then what is remaining? Last one is P is remaining. P is remaining over here and X is remaining over here. Correct? So what we did is, we first found out whichever is the 90-degree angle, that angle we matched with one another. Q we have matched with M, wherever the place of Q was. This is the second place, I have written the M in the second place. From here I have seen whichever is common, R was common, here W is common, so wherever R is there, that the W will follow. So R is in the third place, I wrote W in the third place, and then the remaining part. So my PQR is congruent to XMW. It is not PQR congruent to WMX. If you see, it is PQR is congruent to XMW. So this congruency has to be written very carefully. Once the congruency is written, then you can write the other CPCT. What is remaining? Other two angles are remaining. Q was given, P was remaining. Angle P, you need not even see the figure. Directly you can say P is equal to angle X. Q was given, angle R is equal to angle W. So what I am saying, P is equal to angle X, R is equal to angle W, and one of the side was remaining, PQ is the side remaining. PQ is equal to XN. The PQ is equal to XN. The moment you are writing this, everything else becomes easy. But you should be very careful, you should not make a mistake when writing the congruency over here. So what are the congruency tests? So SAS, ASA, AAS, SSS and RHS. So these are all the congruency rules which we are going to use in the problem solving. Now in the next video we will do the problem solving based on these things, and there's also inequalities. So nothing to worry, just you have to revise these things, and you should be able to mark the things properly in your diagram. The moment you mark properly in your figure, it becomes very easy to solve. So in the next video we will see about the problem solving. See you in the next video. Bye.